There we go. Sorry, I forgot to get the mic on. But when they started asking about it, I started looking into this thing, and I was like, why aren't we using this more? Because our customers pay us to design something. We kind of show them a 3D looking part, but it doesn't really look like it looks in real life, which Visualize can do. So we're going to kind of go in, kind of do some live work through Visualize. We're going to create pictures that look similar to what we see here. And you guys are going to help me so we can kind of go through and basically have some fun with it.
Yeah, I think in general I have a lot of fun with everybody from myself and Brad and myself for our legal department.
Yep.
Working in handshake and collaboration with SolidWorks.
Yep. Yep.
Get all flat screen. So it's on the Visualize flat screen, but hoping the next year with the next iteration of SolidWorks.
Yep, you'll get to see our stuff. Well, I'll pull up one of them and you can kind of see it. But before we get too far, my name's Brad. Everybody calls me Tank. I'm a 9-year employee of Altec as a project designer. Before that, I've worked in multiple fields between the U.S. military, the U.S. government, building parts for aircraft carriers, submarines, that kind of thing. I'm a 15-year user of SolidWorks. Like I said earlier, I was formally trained in Autodesk products, and my first job interview out of college said, if you could draw this coffee cup in this software that you've never seen before until today, then you have the job. They gave me 30 minutes, and luckily I figured out how to do it. And it's been SolidWorks ever since. I haven't actually been able to really wanted to play the other software because it's kind of what I've been hooked on since. So in 2018, I received my CSWE. Like everybody, I came out of SolidWorks world at the time, and I was like, man, I really want to become one of those CSWE guys that has the little flag on the bottom of their badge, because it makes you stand out, because there's only like 3,000 or 4,000 people in the world that have them. And I challenged myself in a year to get all the certifications that I could do it. And I barely made it because I wanted to get it done before 2019's world. And I barely made it, but I did it. So for new users and students, when you get into college, use the opportunities to get those certifications because you're a student, you can get them for free. And you can put them on a resume and say, hey, yeah, not only do I know SolidWorks like this guy says he does, but I've got the paper that says I do. And it's unique and verifiable, and it's serialized so they can actually look it up and verify. So I like doing that.
Chris is probably asking about the CSWE, if I'm not mistaken, if there were any issues in getting the CSWE.
Yeah, yes, as far as failures in the CSWE, getting to it, the advanced classes, the advanced test after the CSWP exam, the Certified SolidWorks Professional, I failed the surfacing one 3 times before I could figure out how to do it. I see a 2 over there. Yeah. The surfacing one was really, really hard.
I passed by the first time, but I think the only reason I did is because I worked at like lynda.com at the time. Now it's
LinkedIn Learning.
As well as Solid Professor. And I used those resources religiously and just studied it and went through it, combed it, pretty confident that finally.
Yeah. So in my abundant spare time of not doing user groups and working, and I'm also a husband and a dad, I do motorcycle ministry, and I'm a technology nerd. And then, I have some more abundance of time that I'm not doing something like maybe sleep or something. Well, we'll just take all that up. We'll just enroll in electrical engineering college as well. So I'm doing that part-time at night once my kids go to sleep.
Awesome. That lets me know there's hope for the rest of us.
Yes. Hey, that's okay.
Yeah, keep going.
Yeah, you just keep trying it and you keep going.
You have different times as far as like how long you have to wait between them.
Yep. There's no limit on how many times you can take an exam. So keep trying. Yes, 2 weeks up until the CSW. Then you said 3 months. Yeah.
You said you got a 14-day.
Yep. Yep, 3D experience exams.
Okay.
For some of them, you can take it within 48 hours.
Yeah.
And then after that,
When they first pushed the 3D experience one out, they contacted a bunch, I guess, I don't know if it was experts or whatever, and said, hey, by the way, we're gonna throw this test out and we wanna acknowledge it during World. Do you mind taking the experience certification while you're here? Okay, I think maybe Scott makes.
I took one as well. It's like an Explorer one, whatever.
Talks about the compass and everything.
Yep.
unfortunately, some of them already have completed.
Yep, then it's, yeah, I think it's gone now. The Explorer one, yeah. So intro to Visualize. So this is kind of what we're going to cover today. And again, I like to do participation with everybody. If you have questions while we go, please feel free. And if I can't figure it out, or if I don't know the answer for the specific topic, we can, I'll take note of it and we'll try to learn it myself so that I can present better next time. So
Is Visualize anything like rendering in 3ds Max?
yes. Yes, it is basically the add-on for SolidWorks, so you can drop your models in. Yep. So we're gonna go over, why do I want to use Visualize? Why do I want to have my company use it? Correct me if I'm wrong. I think Visualize Standard comes with a seat of SolidWorks. Let me see.
I just share this.
All right, so it's stop share, and then this one. There we go. All right. Cool, got it fixed. So if you have a license of standard SolidWorks, you already have a Visualize license. You just got to download the program so you can run it. So everybody who has a license can actually use it. Where to start? We're going to do the options. We're going to kind of go over the outputs, and then we'll kind of do a generic Q&A, or I like to call it stump the chump at the end. So we'll go from there. Come on now. There we go. So why do I need to start using Visualize as an engineer? What's the first job of an engineer? I asked this last night and I got a pretty good answer that I wasn't expecting. It was a pretty good answer. What's the job of an engineer or a designer? Okay. The answer we got last night was to solve problems. And a lot of the times it's through the creation of parts or creation of designs, right? But when you create these problems, or you create these solutions and you want to show your customers before they went ahead and pulled the trigger and make them, how are you doing that? How are you showing them off to your customers? Are you taking printouts? Are you doing Zoom? Are you doing Zoom meetings? Are we doing you 3D printed little prototypes? How would you do it? Well, currently, SolidWorks allows you to kind of, throw your screen up, do some screen grabs, or even do virtual. We call them virtual PAMs. I think is what they are. Pre-something meeting, post-award meeting. That's it. So we can show the customer. They can open up this thing and see this is exactly what they're ordering. But it kind of looks cartoony, right? Do you think the customer wants to see every edge, every line that we see here? The hard edges that are up there. I don't know, kind of, these kind of hard edges and these tangent edges here, and probably not. It doesn't really showcase what they're buying. They're paying for a full, complete product at the end. So I started kind of playing around with the idea of getting this into Visualize and trying to show a customer what they're going to get. And the first one was this, this tester here that was going on the shop floor. And this is what I came up with using Visualize. And being able to go in, assign materials, assign paint colors, even down to the plastic red caps on the lights and these buttons here. These are actual plastic assigned inside. This is assigned paint white or powder coat white, depending on what you want. Yeah, Altec white. But we can go in and customize any of those colors to whatever Pantone color you want. So being able to accurately show what they're going to order and see, this is what I'm paying you to do, not just here, draw me something up real quick and we'll go from there. So pull back over here. Where'd my mouse go? There it is. Oh, no, it's back there. It is. Yes.
So Visualize actually comes with Pro and
Pro and
as
Premium.
long as you're on the subs.
Yes, but not on the standard. Okay, correction.
And you have to be on the subscription.
Yes, okay, so Pro and Premium licenses under subscription, correct. That explains why we only have one license for all of us. So here's kind of an idea. This was the design that we were asked to create for the splash screen, right, for Altec. Yeah, this doesn't look very good. Kind of looks like a cartoon. Yeah, it does. All the black lines, all the edges. Now I can go in and turn the edges off. Yeah, so yellow is aluminum. Magenta, I think, is stainless steel. Regular steel is kind of a gray, but if I wanted to apply some paint color, I can sort of. It doesn't really showcase what this thing's gonna look like. So, you know, having to go in and play around with it, you know, if I showed this to a customer, which we have before shown these things to customers, so they usually come at me with questions of what's with the yellow, what's with the blue, you know, what's with, you know, this blue piece here that's actually plastic, or this whole part right here is all aluminum that's painted. Why is it yellow? So we've gone back to, come on now, go back. There it is. There it is. So this one is the right monitor up there. So we played around with it a little bit. It took me about a month to learn how to throw things into Visualizing, how to compare them. So we have some stuff thrown in. We have painted materials. We got rubber. We've got steel. We got chrome in on this. So if you see, we've got chrome on the chrome rod of the outrigger cylinder here. We've got rubber tracks. I've got even plastic dipped red handles or the safety feature, and the black painted pins, just so that we can make sure we show everything correctly. Because I want to make sure that my customer gets to see exactly what they're ordering. And this is kind of where I started to learn and touch on the software a little bit. It was like, you know, why aren't we using this as a product? Now, for those of you who've used SolidWorks a lot, have you started looking into doing renderings before your product to showcase something? If not, why not? If you've got a chance to do it, there's a rendering platform built into the software as well, but Visualize is a little bit more powerful and gives you a little bit more options. So
How long does it do fabric?
it's got a fabric thing in there. I've never really messed around with it, but I'm assuming you could probably adjust the texture mapping to make it look pretty accurate.
It's not used with software.
So like Blender.
You got used with movement, but for static images, especially once they're
So the question was for the people on the Zoom call, how is it for fabrics? And the answer from TPM Rvar here is, for static images, it's great. But if you were to do motion and animation, that would be where you want to stick with your, as a key shot maybe for that one. Yeah, 3ds Max or key shot. Yeah, either.
You start trying to do mattresses with tufting and things like that, or seats, you know, upholstery. Right. And SolidWorks just doesn't handle it very well. Right.
Yes.
3ds hoping that this might be a solution to that.
Yes.
Happily married to SolidWorks.
Yes, and this is what we're kind of looking to touch.
How much better it be on the experience platform. Like got Visualize on the platform, and that version of it's a lot better because you're not consuming the resources on
yeah.
the machine. It's being consumed.
It's cloud. It's cloud data at that point.
You can sit there and spin it off. Your computer do whatever you want.
And they're trying to get better at the platform to do that.
Yeah.
They're getting there.
That's a big request too, because not a lot of people, or a lot of people also do the fabrics and the plastic sheeting and things that, you know, I just do big steel things, big steel pieces that are, I mean, this thing you see here is the size of a small car and it weighs 11,000 pounds. It's actually one of the smallest things we build in our plant. Oh, who, Ivan? Oh, yeah. Hey, Ivan. But yeah, this was something just playing around and learning it. So yes, thank you. So where are we going to start, right? How are you going to start with it? So to quote Adam, let's go to the CAD mobile, except what? That was weird. I know, that's ugly. We're gonna to the CAD mobile, except we're gonna go to the render mobile, the render wagon, I guess. Uh-oh. Share screen again to screen share. Now, all right, now we can see. Again, we should rename this the technical difficulty SWUG because every time we've gone somewhere, one little thing happens or another. So, I know. So here's your main startup point for Visualize. Now, you can come up here and we can go up into the top and go to new. It'll create a project. It'll actually create a bunch of folders inside the background. It'll tell you where you put your projects in. When you install the software, it'll tell you it'll give you a spot for all your images, all the models that you download, all the materials. It'll let you do all of those features. It's out the way here. So we can come in here, we can actually come in, find a new model we'd like, or we can import a model, which is what we're going to do. And so the best part about this is we can import a model directly from a SOLIDWORKS assembly. Snap to the floor. We want to do it we can import it as we go. And there's a few different ways we can import them. So we have these options here that come up. So this is your part grouping. So if you have parts that are similar material images inside of the software, it'll go with your group if it's grouped together with a color. So if you have everything white inside the software, inside of SOLIDWORKS, it'll pull in white as one group. Black will be in another. As long as they're all the exact same, they'll pull in as a group.
So this is Visualize is not actually inside of SOLIDWORKS.
No, it's outside of it. Yes. Yeah.
Well, you even have those licenses on two different computers. So
Yes.
you could have one person, let's say you buy a pro license, a SOLIDWORKS pro license, you could have one person use SOLIDWORKS on one side.
And it could be a network license.
Yes, network. It could be a network license.
Pretty sure it's pro.
Okay. Same thing. You can get your appearances here. We'll keep going. Appearances, and then if you have layers set, it'll pull layers as well. Or you can just retain the BOM structure that's on the side of your feature tree. Most people find it, for new users, to just go with the automatic. I tend to stay away from this one here. Flatten makes everything individual. That means every part will have to be assigned a color or a texture. Or,
If you assign your materials to start with
Mhm.
and have them as colored as you would have them in production,
Mhm.
can it find that information? If everything is 1020 steel or 414 or 414?
So if you had something that's like 4140 steel versus a 1020 steel, it's going to be a little bit different color. I'm not sure how it will pull and be able to display those two different grays essentially. But it allows you to kind of group them together based on that. And then you can assign all of that one group this specific color once you get into the software, where everything that's this color, you can assign, like I did the Altec white as one already preset. But I tend to stick away from flatten because it pulls every part individually. Not just, if you have nuts, bolts, washers, gaskets, it just makes everything assignable. You can also click monitor file here, which will say if you're working on the rendering. I'll say I'm working on the rendering and Adam's working on the model itself. Every time he saves that model, this software is going to reload, and it potentially might blow up what you're doing. Now, if you're working on the rendering and the model itself, you can keep that so you can keep up with your updated changes. It's just something to be aware of before you try to pull things in. Now, so you've got textures. We've got search for missing textures if you have some. If you have assigned some in previous ones. Animations, if you have animations in there, you're going to need Visualize Premium to do camera camera animation, but it will pull it from the model itself. So if you've got or an animation of you're made expert, moving something around, you can use that as well. Cameras, it'll pull cameras as well, scenes, and any decals that you have set. I have mine deselected because none of the stuff I have inside of SolidWorks has any of the cameras, scenes, or decals in them. So it's just less data for it to look for. So we're just going to go with automatic because this is the little engine I downloaded, the little engine that could.
One more time.
How I got to the load screen. Chris, is that what you're looking at? The load screen? Okay, so what you would do is you go to File, New. We'll just go back through and redo it again. We'll do a new project. Click up in here to project, go to your model, and then import your model from where you're looking. So we'll go back into this engine here that I just pulled in. And automatic. And it gives you a basic background and image. That's because it's rendering as you're rotating. So it's actually doing a quick render every time you rotate it around. So I've got this engine here. Already looks pretty much, it looks pretty good rendered right now. We can make it better. Over on your right-hand side, which is where all your textures and your paint colors, and here's your fabrics you were talking about earlier that you can, these are just basic ones that come in, but you can import more later. Good, because it actually gives you the file type. Looks like a .svap file if you're looking for specific things. So we can go in and just change the appearances of the stuff that's already there. We can change our scenes. We can change cameras and play around with it a little bit. So go back to general, scroll up a little bit. And so here's up here, gives you a little default explanation of all the parts. Come on now, we slow. There you go. Now, this will allow you to kind of pick through the tree of all the parts that you have, and you can actually select certain ones you want in the tree, or you can come in here in your viewport and click the things you're looking at changing. So it kind of gives you double options if you know a specific part name you're looking for, or if you know what it's going to be shaped like. And then when you select it, notice that it's got a little bit of you select a certain part, it'll highlight it with I think that's yellow, but I'm not 100%. So we'll zoom in on this plate here. This one's in red? Okay. Yeah, because this does not help me at all. Okay. So we're gonna go over to our appearances tab. Notice you can actually pick some cloud appearances if you wanted, if you had a cloud library set up, or you can do what's on your local, which is pretty much where I've been working from the entire time. And we're gonna go into automotives, and you can pick different materials. You got lights and things. We've got glass if you want to do glass. We've got, weird gems and things. We've got mesh. We've got metal. So what's a big thing on motorcycles or in hot rod cars? Chrome. We just come and drag it on there, and now it's got chrome on it. Now, I don't want to be one of those guys that doesn't have a chrome cover, that has a chrome cover and doesn't have chrome bolts go on those covers. So I can come in here and drag chrome and just drop the chrome on all the bolts that I want. No, zinc yellow rusts. Shh, nope.
If you did that as a pattern, would it do it as a pattern? In other words, if I had all those bolts located as a pattern,
I can.
and I click on one of them, which is the master one,
You
could I
can
make it do it all.
You could select them in the tree, I believe. I've never really played around with the patterning capability. We're doing them one at a time. That's something that's still relatively new, at least to me. But
it's not going to bring in any SolidWorks features, including patterns.
Oh, okay.
If it brings them in as a group, you can pull it all.
so yeah, if you had them set up as a group of all these specific bolts or one group or a texture to begin with from SolidWorks, it'll pull it in as a group, and then you can select them from there. So it kind of lets you so if you know you're going to go into Visualize, you can go ahead and pre-select the things you want to. I know that this is going to be a different color in the rendering. You can change it there.
And Chris online made a statement saying, based on what he's saying, it looks like the video is very video part driven. That's why it's rendering it.
Yes, it is. Very. So we'll go back to our textures here. I mean, we can come in and we're not going to do this whole model, but I could just throw some stuff in there. Just to get some photos in and whatnot. Yeah, Chris is actually one of our guys from work. Yes. Yeah, Chris gets a gold star for being. So let's do some cool stuff in here. Another one of the big, oh, and I broke it. There it goes. Another one of the big new things coming out is copper or brass on hot rods. I've seen some nice hot rod copper parts. So we're going to throw some copper polished pieces in. And it's just that easy. You know, I want my customer to see it. And then I can update this picture as we go. But it's something that, that they want. So we're going to come in here and let's say this is now brushed aluminum on the case. Actually, no, let's go back. Cast aluminum on the case. Both front and back cases. And now we've got some parts here that are set up, right? Well, does it look fairly good? Let's just pretend we did the whole model all the way through, right? Does it look okay all the way through? Now, it looks good, but what about this background, right? This doesn't look like, kind of looks like not a perfect background for this. It's not nobody's going to sit an engine in a white box, take a photo of it. Come on. We're going to come over here and we're going to come back. We're going to come in and find some backgrounds. We've got our environment, which has all the lighting in it, and then our backplate, which is what you're seeing back of the actual view. So you can change both if you'd like. I like using the high contrast lighting because it gives you lots of reflection and lots of bright edges to show. Makes it look kind of outside, but we can come in here and change all kinds of things. So if you come in here and change your environment, we can come in and pick. So we can do studio color. It'll change the lighting, kind of give you a little bit different lighting feel. We can come back and let's pick Dazzler. I've never seen that one before. Let's try that one. Not very dazzly, is it? No? Okay. So let's go back to the high contrast because that's fairly good. It shows, I don't want studio, I want the ramp. Gives you a good representation of what the chrome's going to look like, where all the light's coming from. But I'm going to change this backplate up a little bit. So notice all I got to do is click on it and it gives you an option to change things. So I come in here and I can pick retail store. Let's go pick this retail store and open it up. Let it do its thing. Let it think. Looks a little big, doesn't it? Well, we can come back. We can change our cameras and stuff, and we can zoom in the part and move it around to kind of get where we'd like. Now, some of these backplates will allow you to update and change. Yeah. So you can sit it around and move your part. Let's move it around here. Oh, no. I broke it. All right. Oh, no wonder I can't see it. I got my stuff all the way around the way. All right. Advanced. So we'll go over here and we can change the size of our background in relation to the size of part you have. So we're going to kind of move this back up to where it looks decent, and we're going to change this thing. Let's go to 6 and just see what happens. And we'll set the height to 10. Wait a minute. Oh, never mind. Hold on. Let's undo. I'm in the advanced of that one, not where I need to be here. Okay. back to our camera here. We can change kind of where we want to sit this thing. We could say height from floor, floor distance. We can move kind of where we want this thing to sit using based on where our camera is at and get our right perspective. This still looks like a really large engine for that office space though. But I mean, it is true. I mean, we could put it in the office. But it's just things you can do and play around with your renderings and get it where you want. So you could even go in and download all these backplates. There's websites where you can. They're called I think yeah. I'm trying to figure out where we had the backplate file type. There it goes. So as you can see, this kind of on a laptop, it's a little bit slower because it's really, really resource intensive. So you probably wouldn't want to have both SolidWorks and Visualize open, but it just kind of gives you an idea of what's going on. But in your environment or in your background here, you can actually take and download any of these. I think it's called an SVJ or any of these here. I think the one I used before was an SVJ file. But you could download any of these and use them as backplates. JPEGs, you can even use, it looks like it even uses GIFs or GIFs or whatever you want to call it. PNGs, it'll allow you to put in any background you'd like. So if you have a picture of your office out front and you want to throw something and render it in your parking lot, why not try it? Get you a really good high quality photo of your parking lot, and then you can start picking your parts in and start throwing. Oh yeah, or the picture of the motorcycle you want to put in your office. And then fool your boss and send him a picture of his office with the motorcycle in it. Do you think that?
Especially when he's working from home for a couple weeks.
Yes, that'd be a great prank to play on somebody. I like that. But yeah, I mean, it gives you, you know, these, I wouldn't say unlimited, but nearly unlimited possibilities on how to get the picture that you want to show your customer. If your customer's got a specific spot on the shop, they're going to build this machine, go in there and get you a really good couple camera shots of where it's going to sit, and then render it where it's going to be. And then say, here, is this what you're looking for? And then you can go.
The way that you can grab a hold of a line in the image. Yeah, I want the model to have parallel to that line.
Not that I found yet, because the way that the background actually is it pulls, at least most of these backplates come in as a circular photo, like that you would use for a spherical photo that you would use for like a VR. A lot of the stuff is set for VR, so you can use it in that way.
If I'm wrong, there was something within the last couple of years, I don't remember if it was made it remote or what. Last year, they did the underwater submersible thing.
Mhm.
They put it on a cruise deck to make it, they were able to pick the wall and the floor. It may have been the platform version.
It might have been the platform
They were able
version.
to pick the wall and the floor
And drop it in.
and drop it in, and it aligned itself with that to be able to hold that.
Yeah, I believe that
So you can still rotate it, scan it, but it'd still be in the right.
be in the right orientation.
That's kind of what I was asking.
Yeah.
Yeah, it may have been the old island that they were talking about, because it was this year's world event when they did it.
Yeah.
Because it was that underwater submersible, they brought it in, showed how they rendered it and everything.
Yeah, because this brings in your backgrounds and backplates as a spherical image that you just sit it in. That way, when you rotate the camera around, it's always got something to look at. Now that, like I said, the platform version, the 3DX platform one, they cloud compute so they can throw as much information at it as possible, and you're not sitting there trying to, watch your. Yeah, somewhere. But let's say we've got this thing out now. Now, I guess it's now time to export it, correct? We can come in here. Let's move this out again. These little controls are highly annoying sometimes. And we can take a snapshot, or we can actually do a full render. So we're going to do a full render, and I'm going to show you just kind of how fast this thing goes. So we'll just SWUG 1. And I want it to be a JPEG, but you get all these options. You can pick. So if you're going to go throw Photoshop stuff in there, if you've got HDR files, you can run that way. But we're just going to do it as an output of a render. And we can do the cameras. If you got multiple cameras, it'll render them all and you have multiple photos, or you can just do just this picture that you're looking at. We can pick our resolution, size, and the actual resolution itself. Or if you have a specific backplate you're using that's already preset, you can tell it to do that. Your render selection, pretty simple. You can pick which one you want to do, fast, accurate, or just preview. We're going to do accurate, and we're going to set it to be quality. And render passes, default, it comes to 250. You can go as much as you want. I think you can go, yeah, 1 to whatever. I don't think I've ever tried its upper limit. We're going to stick with the 250. And that's the number of times it runs the file to actually get your full photo. And just click in here. And then we're going to start. Yes, not the integrated. This is actually dedicated for SolidWorks and rendering and all that. And it's done. So it's ready to go. So we can pull it up. It just tells you where the location's at. So I can come in here, click the copy button. There's my SWUG 1 photo, and we can open it up full screen. And you've got it. And it even has the reflections and stuff in the photos that was inside the office beforehand. And it's fairly good quality. I mean, you can zoom in pretty good. Now, do you think your customer would want that more than just a regular camera screenshot of your part? I would think so. Like, what am I paying you for to give me an artist rendering when I could, or an artist depiction when you can get a full rendering of it? But it didn't take very long. I think when I did my full rendering of this file, this one here, I think it took me a total of 30 minutes to set the floor concrete and then set all the material. It wasn't very much extra workflow to pull all the data to get it done. So it kind of gives you.
It really is fast enough. There's also an application called Visualizing, which allows you to parallel between lots of different sheets.
Yes, like basically format. Yes.
Well, it looks like on the other rendering that you could set the material or whatever for certain parts.
Yes.
Stripes or strips.
Yeah, you can do all kinds of textures. You can do.
Like if you wanted the base material of that to be a brushed aluminum, but you wanted the thin edges to be black powder.
Yep, we could do that as well. But and it just kind of gives you an idea of what you can and can't do. It even these materials down here is. So we can go down and pick up. Let's do our texture. That cast aluminum. You can come in here and pick the depth of the texture. You can make it really bumpy or not bumpy at all. You can even change it to. Let's go to bump from displacement and let's stick it there and then we'll zoom back out. But it allows you to kind of pick and play around and get the most accurate rendering. Come on now, I don't want to see that again. There we go. Most accurate rendering of your part as possible. So just take some time if you have a chance to play around with it and try it. Go back to our PowerPoint here. So we'll skip through because we went ahead and did our camera selections and ISO. So we'll touch on the camera. So now that we'll kind of jump back. Now that I've got a rendered material or a selection of material, I can go and actually pick cameras, much like you pick your SolidWorks views. And it'll sit. Well, hopefully it'll do it. Come on now. There it goes. And it'll pull different views as you need with the same backplate that you've picked. Or you can go and go back to your default. So it just kind of gives you some freedom to play around and pick and get what you need. So that looks a little bit more realistic. Still a very large engine, about the size of a coffee table, but we got kind of what we were looking for. I know this is like a Norton or a BSA. But we're coming up on the end time here in a minute, so we'll just do a general Q&A, kind of stump the chump kind of thing. Oh, come on now, don't do it from there. I know. I'm so used to running it from the beginning, I just repeat it. So any questions either about this visualized thing or just in general SolidWorks problems you run into? I like to do kind of the stump the chump thing. If you've got a question, we can try to solve it or try to break the software.
So does any of the rendering follow the part if I send the customer a model?
No, it's a whole separate file. So if you do send the customer a model and they like it, or if they're going to insert it somewhere, the rendering is just a photo at that point. Yes, JPEG or a TIFF or a PNG, whatever your output would be. It'd be good for marketing for if you're trying to kind of show them what it would look like in place. I do not know. I've never really looked into the metadata because I know that's very advanced.
We just added renderings to our website.
Oh, okay.
We had photographs.
All right, we've made it.
If you've ever tried to photograph something that's all black, it doesn't.
No, it doesn't do well at all. No.
You know, the good thing about the photograph versus the rendering, it's post into engineering changes.
That's true. Yeah, it's complete. You won't ever have to worry about it looking different than with the parts you get. Yeah, that's a good one. Yeah, but yeah, this allows you to actually take those direct renderings and drop it right on your website. Send it to your webmaster and get whatever he needs for it.
I have a question for you. Does this integrate in?
That would be something interesting.
It was kind of a drive work, so like making all these different models. You know, it's
Or if you have things pre-selected in DriveWorks where you're creating the model and then you know you're gonna put it. Yeah. You see it both ways.
Mm-hmm. She's like, all right, got to email my boss now. I highly doubt that.
I don't know, what time did I send you your email that night?
12:10.
I'll tell you, there's been no rest from the.
Yeah. All right.
I thought about calling you about 10 o'clock.
All right, so we'll go ahead and get started. Time's already elapsed. I think everybody's just about back in their seats. So let's see. So my topic today or tonight is going to be on sheet metal. It's going to be advanced sheet metal. Just bringing up a few other things. So when I thought about this presentation, I'd been to World many times, and every time I went to a sheet metal presentation, it was always just basic stuff, right? How do you pick a plane? Where do you extrude the tab? And how do you put a flange on stuff? And so typically when I first sat down, the presenter, which is great, would say, if you know how to use sheet metal and you use it every day, it's probably isn't for you. So I'd get up and I'd go find another one. So that was always great that they gave you the opportunity at the beginning to understand what the presentation was going to be about. Earlier this week, I'm wanting to say it was probably the second meeting we did. I did a beginner's sheet metal. I didn't go all the way to the beginning. I didn't go all the way to how to pick a plane and do a flange. I talked a little bit more about design intent probably with sheet metal than I did anything, but touched on some of the basics. So tonight I'm going to go into a little bit more different features, things you can use and do to make things work for you and maybe your manufacturing team a little bit more as well. And just for fun, I called it mind-bending metal, right? So it's advanced. So about myself, my name is Adam Ebernickel. I mentioned earlier I'd bring it up and give my background a little bit in the presentation as it's a slide. I'm a senior designer in the product engineering department of Altec Industries. We do the bucket trucks, booms, all that stuff. We do more of the body portion of it, just right up the road here in Burnsville. Of course, same trucks that Phil here also creates gears and stuff for us as well. I adjunct in the applied engineering department at Malin Community College, just a few minutes down the road, kind of got into that. Very similar with the SWUG thing as we was talking about early in my career at Altec. I was eating lunch with some colleagues. We had went and seen a 3D printing thing they were doing at the college. The main instructor over the applied engineering department was a one-man band show, and he was very overwhelmed. And so I said, if you need help, let me know. And sure enough, he took me up on it. And ever since then, been working alongside with him and helping him out, and he's been helping me out, and we're just kind of chugging along at it. It's a great opportunity. I do co-lead the Western North Carolina Asheville SWUG group with Phil Bim. Been doing that for the last few years. Like I said, I've been with Altec for almost 10, so it's probably been a few years minus that. Kind of like the college thing. It's been a great opportunity as well, being able to come in and work with the user groups and just absorb all the knowledge and camaraderie and networking and everything that goes involved with it. About 3 years ago, I was chosen to become the SWUG committee member, right? SolidWorks User Group Network committee member for the whole Southeast region. So any user group that's in the Southeast region, I'm basically here to support them and help them through any problems they may have, whether it's coming on board, becoming a new group, or finding new leaders, or just getting information or presentations or anything of that nature. Not too long ago, probably about a year or two ago, they came out with a SolidWorks Champion program. So I decided to, kind of like Tank over here, why not? Got plenty more time, right? Cut out a couple more hours of sleep each night, and we'll just add this to the list. So SolidWorks Champion Group's a great opportunity. It's just more of ways to give back to the community and share what knowledge we have and the passion that we have with different individuals. I am a SolidWorks certified expert. My path to that was probably a little bit different than Brad. Brad said, he seen the badge, he wanted that badge, and he tried to get it done in a year. Mine was, I just thought it was cool, and I guess kind of same as Brad, but thought it was cool and just wanted to get the certification. So I went through it, got the A, knocked it out pretty quick, got the P, knocked it out pretty quick. And then I started getting stagnant. I started doing the advanced sheet metal, advanced surfacing, and all the professional advanced exams. But I did one here and I did one there, and I slowed down on it, and I took more time, I think, researching the stuff. But I was also getting caught up in work, and it just wasn't making time for it. So about 3 or 4 years ago, my boss looked at me and my performance evaluation at the beginning of the year, and he said, you know what? I'm going to put this on your performance evaluation that by next year, you're going to have your expert and be done with it. So, after that was said, I think 2 or 3 months later, I was done and I had it because, just us busy people, you put something on our head or on our plate, and we just got to clean that plate, wipe it off, and put it up for something else to come along, right? So that was kind of my experience in getting there. So today we're going to talk about that advanced sheet metal. Some of the key takeaways we're going to look at is how we work with sheet metal and some of those features that are there, how we can manipulate sheet metal parts in different ways. And one that I like to focus on here, along with some other stuff, is rods and pipe with sheet metal, right? A lot of people just want to sweep it and extrude it through a sweep, and maybe they create the bent pipe or the bent rod, and then they go back and they sweep one that's straight so they can manufacture it. We'll get to that here in a minute, so I don't want to get too ahead of myself. I do get excited when I talk about some of these things. The very first thing I want to talk about is sheet metal, and I brought this up in the beginners. I just didn't go as much in depth, just kind of brushed over and said, okay, gauge tables or manually inputted information, right? Gauge tables is going to be a winner chicken dinner every time, right? When you go to create your sheet metal part, if you have gauge tables that are developed and in the background for your file location to be able to find that information, you don't have to worry about mistakes. Unless they're, of course, they're inputted there incorrectly, but at least they're going to be consistent mistakes, right? Because whatever you do, whatever you tie to this sheet metal or gauge table, everybody is going to do the same thing. If you've got 50 employees that are bending sheet metal on SolidWorks and you need consistency for your press brake operator out there, get in with gauge tables, right? It's very simple. All you do is create an Excel spreadsheet. You can basically look at this slide and create it just like it. All you need to do is, say what type of sheet metal table it is, how your process is, your K factor, your units, and then you just build the columns out to where you list what the thickness of the sheet metal is and the gauge thickness and then the bend radius, right? We have a few different ones through our different organizations and some share the same gauge tables, but that's only due to the fact that, you know, maybe at our final assembly plant, they want to be a little more precise because they've got some tolerancing thing that have to do with some critical units, right? And so they may want to go to 4 decimal places, right? As where we may only want to go to 3 decimal places. So that's a very important key factor here too. You don't have to worry about somebody going in and inputting the information with the wrong decimal place or even the wrong number being off by a fat finger. Who's guilty of fat fingering things? I know I am, right? And so you can label out different ones. As you label them out, you can have one for, like you see here, aluminum, stainless steel, aluminum tread plate, and regular steel tread plate. But notice, as I mentioned, one of the last things of the key takeaways, I've also got steel pipe and steel rod there too. We'll discuss that here in just a minute. Now, when you develop those gauge tables and you create them, you want to save them somewhere, right? You typically put it in your program files where you want it to live, or maybe you put it somewhere else where you want it to live. But the biggest key to it is to make it work is to go in, not while you're creating the sheet metal, right, where you go search it there, but go ahead and put it in your file location. So open up your system options, go to file location, look for sheet metal gauge tables, and either delete what's there or just add the extra link to your new tables, right? And you don't have to add each table individually, just add the folder that it's at so it can reference that location.
CAD admin people, this is a big thing.
Yeah.
Get it done before your guys start using it.
Yep, exactly. CAD admin people, when you install your new version of SolidWorks, when you're upgrading or whatever, point your stuff there, set that stuff up, and then roll out. When it rolls out, you roll out the copy settings button, right? And you just restore all that to the PCs that as they get loaded, right? Then all your stuff, and that doesn't just apply here. That applies for your templates, for your line weights, your document properties, all that stuff that will really benefit your company as you put that in at the beginning of a rollout. Now, keep in mind, document properties won't go back and fix old stuff, but you can easily bring it current. And then as you move forward, it'll help. So, sheet metal gussets. This is more of a warning than it is anything. There's a purpose for them. I know there is, and I'm sure people use them. But there's a lot of issues with sheet metal gussets, right? The flat pattern will actually ignore the gusset and just flatten the part as if it wasn't even there, right? The sheet metal functionality will not account for any stretch, deformation, thinning, or anything of that sort caused by the adding of a gusset, right? Now, unless you're stamping a part and you're trimming the edges afterwards, it's probably not ideal to use them, right? Because if you just say, okay, I'm gonna have my breast brake guy out there, just go ahead and put me some sheet metal gussets in to stiffen this guy up, it's probably gonna tear the metal. I mean, if you put some big gussets in there, it's just gonna rip it right through, right? Not to mention the deformation of how it might come in as it tries to pull the metal in certain places and stuff too. So yeah, unless you have a stamp process that you're using to stamp these in there, and then you come back to it later and trim everything around it, it's not even worth it. So that's the only reason I show that. We can go into it if we want to. I really like my new slide. I was telling Brad about it last night. If anybody is an old head and remembers Pinky in the Brain, right? And Pinky comes up to the brain. He says, gee, I wonder what we're going to do today, Brain. Same thing we do every day, Pinky. Try to take over 3D Experience World, right? So if anybody remembers Pinky in the Brain, it was just take over the world. But yeah, so to the CAD lab. Right here. All right. Let's see, where are we living at here? Okay, so here's our sheet metal gussets. It's basically, you just have a piece of sheet metal. I'm just going to kind of do this for just basic illustration. Let's press this guy. When you create your first one, you're simply going to click the faces that you want that gusset to go to or go between, and the edge that you want it to kind of point at, right? Or vertex. As you do it, you can set the offset of how far you want it to be off the edge, right? And then you can set your depths and your angles and all that stuff over on the left-hand side. The next thing I did pretty much after that is I just went ahead and I patterned it out. That's pretty simple linear pattern, right? Told it I wanted 3 inches off the other side just so it matches. Any questions about the sheet metal gussets? I mean, they're there. It's definitely able to be taken advantage of, but just to warn you that there is some issues with it because it doesn't show any kind of stretch or deformation. Same thing with forming tools a little bit too. And we'll get to that. Okay. All right, so forming tools. Forming tools are a lot of fun. We use them a lot at Altec, whether it's to do louvers or what's similar to a tread plate to put a little knurled knob up, you know, for people to get traction on when they're walking. But the basic thing about forming tools is you have to know the tool being used, right? If you don't know the tool being used, you're just throwing stuff on a part just to say it's there. And then you get out the shop. Let's say you made this little louver tool, right, as a 2 inches long, and then you pattern it out 3 inches out, right? And you start that pattern. Well, what if it was a 4 inch, right?
What's the backside of that patterned gusset look like?
Oh, yeah. We can go back there and look at that. Backside of the pattern gusset. So let's just back up just a moment. It's basically a recessed indentation. Yep, just like that. Just as if you had a die or you're stamping these out. You can change the radii of this too. So that way it looks different as well. And that's all, again, based on your tooling. No different that is with the forming tools. The sheet metal gusset is very similar to what a forming tool would be. You're going to have a tool that would actually do that. And of course, the gusset size and radii and all that stuff, that's all going to be independent upon the tool that's used to press it.
Like you said, take it to flat pattern.
Yeah. So yeah, check out the flat pattern on this guy. So let's go and just look at the flat pattern. Oh, you got yours set up. We traded machines, so he's been working with all my crazy hotkeys that are different. Now I'm on his machine today, and I'm doing this. So yeah, let's look at it. I got it in an isometric view, and let's just look at the sheet metal. It doesn't account for it at all. Not one bit. It's just a flat piece of metal. And we all know when you push a piece of metal in, it's going to stretch, right? It's going to have to give somewhere. You put a huge gusset in there, like I said, it's going to rip right through it. It's going to shear through it, right?
I wonder what logical case you could call to use that. I've never seen anybody use a sheet metal.
There's a few other little glitches that kind of work that way. Forming tools can do some of the similar issues, but you can account for that a little bit more because it's stamped into a part and it usually has they're not huge. You're not really trying to tear into the metal as bad. And usually you have an opening like a louver that helps out with it. But there's also some little curvature, yeah, because it would just suck in.
And that's how we kind of overcame the problem.
Yep.
Flat patterns is we have outward facing.
But it'd be great if SolidWorks said, you know what, we should probably account for that somewhere somehow. I bet there's a lot more to the algorithm in the background, especially once you start doing patterns and you put a plethora of them in, right? Plethora of patterns. That's
Chris
just to
also
highlight.
has to do an event to show how to create forming tools.
Yeah, I'm going to do just a little bit here.
Okay.
Yep. So I say a plethora of them, and I do that as a spin-off of Brad's presentation this week. He did plethora of patterns, and that just brings me to a moment just to put a plug in that all these videos or all these presentations we've done over the week have been recorded, and we're going to get them out to everybody. So if you want to go back and relook at any of them or see what went on or what the plethora of patterns was about, then yeah, please check into that. Eventbrite has had the listing for everybody to visit it virtually if they wanted to, but we're going to get these videos out to you as well. All right, so let's go back to the louver slide. And when I was talking about the louvers, you got to know your tool, right? That's the biggest thing, because typically you have a stamping process somewhere. It's probably done by punch. I guarantee you a laser or a plasma is not going to put a louver in for you, right? So you have to have a punching machine of some sort. Now, to start with the louver tool, let's just jump over to a louver. Did it open? Did we see it? Yeah, it keeps jumping back. Where's SLD? Should be there.
Yeah, put it in
Do
there.
you see it?
Louver panel.
That's the panel with it. I could probably pull it from there.
Try it.
Okay. Yeah, I've got it in here, so I can unsuppress it. See if I can grab the tool and open it. No, it's not gonna let me grab the tool and open it. All right, so I'll go ahead and just create one for you real quick on the fly. Again, this is live, right? Didn't account for it. So when you model your tool, right? Because basically what we're modeling is the tool. We need to know the radius of the tool, the length of the tool, what type of tool it is, if it's going to actually shear a portion of it, so we know what we're going to open up and show open to the sheet metal, right? So we have to know that information about the tool. I'm just going to use something generic. Let's see. Let's go to the right plane and see if you got extrude boss in here. No. So we're going to go up here. We're going to go extrude boss. Now I'm just going to draw something fairly generic. Let's start out here, up. I'll give it a little bit of a taper here. I'm going to come back to the dot. Anybody know what happens when you come back to the dot? Turns it into an arc. And not only that, but whatever quadrant you come out of that dot is where the arc starts. Come out of the dot. I'm coming out here. So I want to bring it down. And then I'm going to come back to it again because I want to bring it and come here. Right? Now notice what I did when it came out of the dot, it actually created what kind of relationship? Tangency relationship, right? Because it also insinuated with a yellow box prior to that it was going to do it, right? In my previous, in one of my previous illustrations, I think it was last night's presentation, what button can we hold down to temporarily turn off the snap function and not create relationships or snaps? The control button. Control button. See if we come in here and I was to draw this line, this is just referring back. I draw this line. See how it's giving me a yellow line? That tells me that it's assuming I want it to be horizontal, so it's going to create a horizontal. If it was a white box with a line, then it would just say, I'm assuming that's where you want it, but I'm not going to create that relationship. But if I hold down the control button, now look what happens. Right? No different than if I'm trying to come over here, see how it's giving me a concentric relationship? But if I hold down that control button, now I can put it anywhere I want, and there's no snap relation at all. Right, so just a tip and trick from last night that I reiterated today. All right, so we're going to go ahead and we'll just say that's fine. We want that to be like that. So let's go ahead and check that off. I could also use the D key to bring this down to me and bring the breadcrumbs or the confirmation window to myself. I want to go about the mid plane here. I don't know. Let's make it 2 inches long.
Very bottom point. Radius.
Yeah, I see that. Let's just go ahead and come out of it and come back. So we know we can click this line and this line and make them tangent, right? But everybody knows you can also just click the point and do it too, right? So let me go ahead and put that back at isometric. We're going to bring the D key to me so I don't have to go fetch the confirmation window. Now we're going to come back to it and we just need to create the extrude.
Nobody would be upset that was not defined.
It was not. You're right. Because we define every time. All right, so I've just got this basic louver. I'm not gonna go into depth and just trim and fill at the radius and all the edges, because I could go in here and create an axis and draw that down, right? Just, I could actually convert entities, create an axis, and I could rotate it down 90 degrees on each side. Well, all right, so now go to our forming tool command. Notice what I used. I used the command search, right? I didn't want to search for it on my buddy's machine. So I went up here at the command search, make sure you got the command listed. I typed in what it was. I can say forming tool. I can click it to execute the action. I can poke the eyeball to show me where it lives, or I can drag it off on the ribbon, and then my buddy's got forming tool living there until he decides to get rid of it. All right, so we're going to go ahead and do it. We're going to talk about the stopping face, right? The stopping face is where that tool presses into the metal and then stops, right? So say you've got, this is the tool, right? And this is the back plate of that tool. This would be the stopping face, right? Now, if we have a face to remove, which in a louver you do, right? You're pushing this through, you're removing this face here. So we click that for our removal face. Now, notice it changed colors, telling us, hey, this is a forming tool now. We have your stopping face ready, and which is indicated by like a teal or whatever you want to call that color. And what it's whatever color you designate it to be in your color options, right? And then you have your bottom face, which is red, showing that face is going to be removed, right? Red, delete, makes sense. Okay, now can we just save this out? We have to save it as a certain file type, right? Actually, SLDR may work. Yeah, right here it is. Forming tool, SLD-FTP. So we have to save it out as a special file type. Now, the thing to know is, where are you saving your forming tools? If you're going to use them later, you got to know where they're at, right? Somewhere something is going to need to reference it. So for this purpose, I'm just going to save this in the folder that Brad and I have shared here for the week, which is SolidWorks presentations. And then I'm going to go ahead, and I bet it's in there. I bet I'm just not seeing it when I tried to open it because I didn't label it. But so this is going to be a second one. I'll just throw it in the main folder, SWUG presentations part 1. Okay. Now it's there, right? But how do we access that forming tool, right? So if I go ahead and tab over to the louver panel I was using, notice this one's a little prettier because I did it ahead of time and made it look a little prettier. But we have to pull it from our library, right? Well, we have all these library options, and a lot of them are custom, but I don't see, I'm confused. Where is it, right? It's not there. Well, we have to set that file location. So we got to have to come up to our system options. And this is the same place that Alex had asked earlier about the location for the diameter symbol stuff, right? So it's going to be kind of in the same place. It's going to be in a different drop-down menu, but kind of the same place. So system options, about halfway down, we're going to go file location. Then we're going to come down here and we're going to look for our forming tools because we want to add it there, or our library, sorry, not forming tools. We want to add it to our library. Where's our library at? Right here, design library. We want to add it to our design library. Now we need to add that location. Where do we put that? You can have all kinds of forming tools or sketches or, you know, whatever you want to be able to drag into stuff and just add it in one library wherever you want it. So we're going to add that location. Look, it already defaulted to where I just saved it, right? So we're going to go ahead and select this folder. We don't need to select the part because if we select the folder, which is listed here and what we're in, it's going to pick up anything that's in there. So we'll select that folder. Notice I added it here. Now we say, okay.
Ask you, are you seriously trying to add this back?
Yep.
I don't know why it asked you twice, but it does. And yes.
So actually.
Now the computer's trying to make sure that we're okay with modifying options within.
So a quick little note on this that trips up a lot of people is if you say this, then what you're doing is you're changing that path for all users on that machine.
On this machine,
That's
yeah.
fine.
If you click no,
But only for the current user.
That's very.
And that's why it bounced into that. Yeah, that's why I went for admin, asked you yes or no. I don't know if you guys seen it because I know we're sharing screen. Sometimes when you share a screen, you don't get to see the admin pop up that comes up. But it did ask for admin permission because we did change it on all users and not just a local user. All right, so now that we open the library this time, look what we have, SWUG and presentations. But is it that easy? Can we just drag it in now? Nope, not yet. Not yet. One more step and we can get there. Exactly. Thank you, Chris. So one more step and we can get there, and that's called right click and make this a forming tool folder, right? I was going to ask you a question after that. Would you like to do it for all the subfolders too? Well, I mean, you can pick yes or no. I don't think it's going to really matter. So I'm just going to say yes. But now it understands that this folder is holding tools that can be used for forming. So now we can grab that tool off and punch it through. Oh, keep using your middle mouse wheel. And look what it did. Now we know ourselves, if that wasn't radius, that's going to shear that out too. So we could have actually told it to remove those faces as well. But yeah, that's basically how it simply works. Just a quick reference of it. Another tip and trick for forming tools, when you're creating them and after you create the forming tool, you can go back and pick reference locations and points so that when you click those reference locations and those points, when you go to modify the sketch forming tool inside of wherever you placed it in whatever sheet, then you can kind of locate it a little bit better and add dimensions and make sure we what? Fully define. Every time, fully defined. All right. All right. So we went and showed that. May have spent a little extra time on it, but that's good. So we understand how we create the forming tool. You see in the left side picture, it kind of shows we got to pick the face and the faces to remove. The right side picture, make sure we remember to locate the folder and make it a forming tool folder. And of course, the application. We already went to the CAD lab. Tab and slot. This is a newer feature for, what was it, 3 years ago? They added tab and slot 2020, I think, version. Is that right? 2019? Okay. So 2019, they brought tab and slot. It's a beautiful feature. Works great, except for us at Altec. We can't use it. And I'll tell you why. It's a great tool. It's going to really benefit your shop guys. When you talk about design for manufacturing, using this forming tool method is great because, and for you too, really, because, I mean, technically you don't have to dimension where parts are located, right? You just tell them, plug it in like a Lego and it's going to fit, right? So it's great. The downside to it, what we have issues with is we don't deal with external references. We don't agree with using a lot of external references because you got users that'll go in and break stuff and tear things up and wreak havoc on everybody in the whole company, right? And our PLM has issues with it as well. That's correct. Our PLM has issues with it as well. So when you create a tab and slot, you basically just do it within an assembly. There's actually a feature there. I can kind of show you where it lives. But there's a feature for tab and slot in your assembly, and you click the face you want. There's a lot of modification things you can do it. You can click the face or the edge of where you want those tab and slots to be. You can give how much gap do you want between the tab and slot. So if you're thinking about tolerancing, right? Do you want it to be a 1/16 inch overall bigger, right? A 32nd on each side. Also, you know, would it fit better? Two things. Would it fit better and be safer if we radius the edges, right? So that way you don't plug a square into a square. It kind of has a little radius of forgiveness to slide right in. Plus, you don't have people worried about cutting their hands on it as easy either. So yeah, there's a lot of things, but what it does is it links itself in an external reference way, because if you modify one, it updates the other. If you can break it, don't get me wrong. I went in and done it. I've fooled with this thing till my brain caught on fire because I was so ticked off that we couldn't break external references. But the minute you break it, it's done. You create at that point, and I talked about this with, I may be talking about it here, but with flanges, are flanges fully defined or not? Because the sketch says they're underdefined. The answer is yes, They're fully defined and underdefined for the reason that the sketches length is actually based off of the feature. The feature drives that, not the sketch. But the minute you change the sketch, right, in that feature, then it deletes the reference of the feature. So then you can no longer modify the feature, right? And so this is kind of the same way. It's driven by the feature, but the minute you blow the external reference, you might as well have drawn it yourself because you got to go in there and dimension everything out because it's all underdefined at that point. And then the whole point is to have it where it's linked. So when you change one, the other one changes, and now that doesn't happen, right? Let's see, to the CAD lab. Let's go look at this guy a little bit. What's our time? Okay. So again, you kind of see how this thing is. It's got all these different features. If you minimize, when we do shift what? C to close all that stuff down. Do what?
Can you guys see that they're externally referenced with the arrow that's pointing?
All right. So we got these tab and slot features, and if we edit or modify it, notice the part edit paired to the tab feature instead, right? And as we edit this one, it allows us. So you're not editing the slot side, you're editing the tab side, right? And then it's going to link it all back together. Now here's where you select the edges and stuff. And you when you first do it, you're going to select the edge in the assembly part. And actually the way you do it, I'll just go back and do it this way. Okay, we don't want to do it. Go away. Because you edit the part in place. So for example, this guy, if I come in and edit it in place, notice as it turns a teal blue, we can go and modify here. Now, when you select the tab and slot feature, you're basically editing in place. You select the feature, you pick the edge that you want, right? As well as the face. I'm using your middle button again.
Got a middle button and a middle wheel.
Yep. Tank's got the 3D connection one, so I've got 3 buttons and a middle wheel, and I'm used to the middle wheel spinning the model, but his middle button actually does it, and that's why you're seeing some of that come up. All right, so you notice it's basically told us the faces and everything. If we come back into the feature, we're accidentally exited out. You've got the different faces you're going to select. You're going to tell the offset that you want to have, as well as the length of it, as well as the tabs, right? What you want to do with the tabs, how far you want them to go down in. So maybe you're doing some kind of plastic or something, and you've got the ability to just only go so far deep. This is the edge type. So whether you want a square edge, chamfered edge, or radiused edge, right? And how much you want that, as well as the gap distance around it, right? So on the edge, we only had a gap distance on the side. We do have one on one side too, so I guess we'd put it there, but this is gap distance all the way around. So you got it on the sides and then on the front and the back. But again, we have no external references with our company, so we keep that checked. And if you want to break them, you can. So if we go in here, we can right click on this. Where's it at? Break external references. External reference right here. All right, and so we can select it and tell it we want to break the selected reference. But again, that goes back to what I was saying. Once you break it, it's just pointless to even have had it and created it. Okay. Next thing, detached flange. Now, I'm not going to say everything in this advanced sheet metal is going to help you on a certification somewhere, but this is what helped me on one of my questions of the sheet metal exam, right? The professional advanced sheet metal exam. There was one where they wanted you to bring a piece of sheet metal to a certain point, and it had to be, everything about that was dimension. You didn't have a lot of dimensions about everything else. So I'm thinking about that. I was like, okay, what if I want to make this little box that, I don't know, held my bolts, right? That I could hang on the wall, right? But I knew I only had a certain space. I was confined to a certain space, right? And I wasn't really sure of the angle on the back, but I knew how deep I could go in the top and how deep I could go in the bottom, right? And so, I mean, sure, we could throw a plane up there and possibly do something. We could guess at it a bunch of times and maybe model up the place it's in and see if it fits, right? But if you know the top, how deep it needs to be, you know the bottom, how deep it needs to be, you can actually, throw a plane or whatever, or offset your tab feature and put it at the height you need it. So you know the bottom, and you just tell it what height, or use the plane, bring the plane up there and extrude it down instead of above the plane. And you set the basically the limit of your height of your feature, right? Now it's not connected, and you see that in the left one. But the minute you select add a edit or add a flange, right? Do the flange feature, you can pick the edge of the top one and the edge of the bottom one, and boom, you've got a tab or a flange that meets it and puts in the rest of the information for you. You didn't even have to figure out at what angle it was going to. Automatically did it. There's a couple other things, you had to add a tweak on this thing, just kind of playing around and messing with it. Now I was bringing the other flanges out on the sides, and I bring them out. And of course, you have to know whether it's inside, outside. We got into that a little bit in the last one, so I'm not going to cover too much tonight on that. But the inside, outside, making things level. Sometimes you even need to do an offset flange, right, to bring it up to a certain point, so you can click those. Bringing it out to that certain point, it was easy, just click the vertex so it knows where it needs to go. But what do you think happened? And this is what I was going to say earlier, Tank, and I forgot about it. We talked about, the sheet metal gusset, and it's like, why does SolidWorks not think of this? Why do they allow people to be able to draw things and then flatten it and it's not real? Well, guess what? There's other things in SolidWorks that kind of let you do that too, and that's maybe overlapping flanges in certain instances. You can't overlap a flange, it's not going to work. Or drawing metal, right? So let's say you have a notch in a certain corner a certain way, and when you lay it flat, it's pulling from the same metal. That's another little glitch that's in there. It's hard to account for. So there's some other sheet metal things you need to think of. When I did these side flanges here that I was just pointing out, after I created the angular flange, where's my mouse at? There it is. And these side flanges here, of course, I wanted to drop it down straight. But if you remember in my earlier sheet metal presentation earlier in the week, basically I edited the flange, right? You can do it as you're creating the flange, or you can go back and do it. Right. And I changed it, instead of being, parallel with that other line, I just said, just make it flush. And I actually created a collinear relationship between the flange at the top and the flange at the bottom. Right. And everything lines up and everything's happy. Okay. I won't go into too much detail with that. That's pretty self-explanatory. Make a plane, draw the plate where you want it, and then just start connecting. You just pick one. You just do the flange feature. When you do the flange feature, just pick both edges and you've got it. Again, that helped me out in that tight spot. We'll skip this. Here's another one that may or may not be on that sheet metal exam. And I don't want to say all these are, because they update it and change it all the time. And the questions I got might not be the questions you get, right? But something that every SolidWorks and sheet metal user needs to know is how to create sheet metal off of a non-sheet metal part, right? But not only how to create a non-sheet metal part off of a sheet metal part off a non-sheet metal part, how many people think that bottom right-hand picture can be formed into that other one? Be pretty darn hard. You'd have to have some kind of crazy stamping process that did multiple things, because once it's a closed box, right? You can get the press into half of it maybe, but good luck closing it up unless you put a hand bend process in there where you notch out all the material in the radius, right? And one of the bends, and put real thin features so somebody can go back and hand bend it, and then maybe you weld it back up. Who knows where you get your rigidity back from. So think about that when you create things with sheet metal, is can it even be bent after I do this? Where do I need to put my stop and starts at? Do I need to do it in multiple parts, right? We'll look at this guy a little bit, because this is kind of fun. All right, to the CAD lab. All right, so in order to create a sheet metal part, a lot of times it's pretty easy. What if you had somebody, and this happens a lot with our company, especially co-ops and people from the old school days where they created sheet metal maybe off of a base flange. I mean, not a base flange, but a boss extrude, right? And so they just create them and put fillets and all that stuff in it. And now you got to turn it into a sheet metal part. So it can be calculated for and it can be flattened and those kind of things, right? Remember that flattened thing, because it's going to be one of the last things we talk about with another solution that I'd come up with. All right. S key for search. I heard somebody else call it something else. W key, I think somebody said. Maybe they just changed it to theirs. Really?
Repeat that in the chat.
And can you say that one more time? What was the button you use?
Yeah, so you press the S keyboard.
The S key?
Yeah, S key.
So the S key is usually your shortcut menu though, right?
Right, so that'll bring up your shortcut menu, but it also puts your cursor up there in the search bar at the same time in 2021 and
yeah.
2020. In 2022, your search bar for searching for applications is
So W
in your
button.
shortcut bar.
W button works as well. So I had the professor at Georgia Tech who runs a SWUG group down there for Midtown Atlanta. He had mentioned the W key. So the W key actually takes it up there without the search, without the
shortcut bar. Or with
And what was the
shortcut
second
bar.
thing you were saying? I'm sorry.
Yeah, so pressing the S
2022.
key will put your cursor up there for 2020 and 21. For version 2022 and 2023.
It brings it to you like
It brings
breadcrumbs.
it to you. Well, not like the breadcrumbs. It's actually just part of the shortcut bar itself.
Oh, so it lives in the shortcut
It lives in
bar.
the shortcut.
That is really cool. So yeah, I'll repeat that. You may have heard it, but yeah. So of course we had Marty, just to give that out. So you could hit the W button and that takes you up there so you can automatically start typing. Our VAR here, TPM, mentioned that if you hit the S button, not only does it bring your shortcut bar up, but it also allows you to start typing as well, just like the W button. And the new version of SolidWorks 2022 and 2023, not only does it give you access to it, but it actually puts the command manager or the command search in your shortcut bar. So that now you have the shortcut bar with the command manager living inside of it.
That's to do the detached flange at the top to actually show the detached flange.
Yeah. Yeah. If we got time, I'll go back to it. All right. So yeah, we're going to go convert just because as I repeated earlier in my peripherals presentation, I don't use the command manager of the ribbons. Actually, in my last night's presentation, I challenged people to get rid of it and use all hotkeys and mouse gestures, right? And as we talked about in my peripherals thing, all my hotkeys are different than Brad's, and I have macro pads that do that stuff for me. So we're just going to put it in here, and we're going to see where it lives. Right there it is, right next to our base flange. All right, so in this, we're going to talk about, let's see, we're going to talk about bent edges and faces and where we're going to start. So I'm just going to start on the top. And now it's asking you what edges that you want to be part of that. Where do you want that to wrap, right? So let's think of this being a piece of sheet metal. We just laid a piece of sheet metal on top. Now to where do we want to go? Do we want to bend it down the back? Okay, let's do that. So we're going to bend it here. Now look, that sheet metal just bent down. We're going to go to the next edge, and we're going to say now we want it to bend here. Okay, well, maybe now we want this one to bend out this way. So now we're going to bend it that way, right? So you're first picking where you want to start with the sheet metal, and then you're picking the different edges to come around, right? Also, another thing to be careful with this, and I'll show it inside of another one, just for the better example. Let's go to our gussets, right? Notice the way this laid down, right? When we went to our flatten, it basically held this down and folded the top or the 90-degree up flange down, right? In some instances, especially if you have an older sheet metal part and it's in a drawing and you change some things, it might not be matching, right? Your views might not be projecting the right way. And that's usually because when you come back to your sheet metal part and you expand here, go ahead and right click and edit the feature. This face is not picked right. That face is the face that you want to be held down to the machine or what you're holding when you go to bend it and how you want it to be depicted on your drawing. I know I touched on it in my earlier sheet metal, but I told everybody I would touch on it more here. And that's basically where that comes from, right? So we want to pick the face. So watch if I change this face and delete it. And now I pick the back of this face. See how that changed? Let's go back. Let's form it. Right? And now let's flatten it. See how it flipped down now? So that's big, especially when you're looking at your drawing and you want to know how things get bent and the projection and stuff. But if you ever have an old school sheet metal part that the projected views aren't right or something, always come here and look first, because sometimes it could be that very well be the problem.
Sometimes if you choose the top face or the bottom face,
It flips it. Yeah, it'll flip the part. And that's where I've seen the most issues from on the prints, is because the projected views are the opposite of what they should be because somebody's flipped the flat. Exactly. Yep. All right. Now, do you have a sheet metal tab for your rods and pipes? Of course, if you're using rods and pipes and that's all you're doing, you might not use sheet metal. And I mentioned this in our second presentation of the week. We were actually at a American Steel Pipe Company, the Birmingham Community SWUG. All right. Their company kind of has a lot of members in that one. And so they were talking about the pipe and different things they were doing and weldments and things like that. So we gave a lot of advice there and had some presentations. But I did bring this up just vaguely due to a question. And I said, guys, tune into this meeting and you'll be able to learn more about, bending sheet metal and pipe. So as I spoke in the beginning, a lot of times, and Altec, we were guilty of it for the longest time, where we would take and sweep our pipes and rods. So what if you needed a pipe and you were making maybe a grab handle, or maybe you needed something to drain a certain way or flow a certain way, and you're putting elbows on it, right? So most people would draw on a flange or on a plane. They go to the top plane or side plane. They draw the diameter of what their external diameter was for whatever given pipe or rod. And then they would go to the other plane and draw the path for that to sweep. And then they just sweep it. But then they're like, oh, well, I got to have a flat for somebody to bend this and know exactly what to bend and where the radius is, the middle of the radius is, and all that. So then they would go back and they would do a display state or a configuration, right? And typically a configuration in that perspective. And they would say, okay, let's just put a circle sketch out here on this plane and let's just draw another straight line on the other plane and sweep it along that, right? And that will be our flat. That's what we'll give to the shop. Well, as we all know, we talked about it with the sheet metal gussets, that when you put a gusset in something or you bend a piece of sheet metal, it has some stretching that's going to go on, right? So, and that's based on your radius, your inside radius, or your midpoint of your bending process and all that. And so you have some calculations to be able to calculate, because it's going to wind up being a little shorter than what the overall length actually is. You can do that, and that's fine. You can figure those calculations up. They don't take a whole lot of time, but think about it. If you're doing that a lot, it's going to suck, right? Maybe you have a spreadsheet that does it for you, and you just put the numbers in there, and it gives you that answer. Kind of like DriveWorks is great for. DriveWorks is great for putting a number in, and they can build this for you, right? But what if, back when I showed you the gauge table, you have a gauge table set up strictly for rods and pipes? Maybe you have 1/2 inch rod, 3/4 rod, 1.5 inch pipe, whatever, and the radius that's going to be bent on. So when they stick that pipe or rod into the table and they crank it around that big wheel, right, the big die wheel in the middle, that what radius they're using for that die. Right. So you build your sheet metal, you build your rod and your pipe gauge table based off that information, just like you would sheet metal. Then when you draw it up as a square or cube shape extruded out to the length you need it and the path you need it, just like you would a piece of sheet metal. Then you come back and say, okay, well, if this is a 1-inch diameter pipe, then I need to go in and make all my 4 corners of that piece of sheet metal. Now I need to make those a 1/2 inch radius. Then it's round. It does a few things for you that way. Because it's done that way, you have edge points, right, that you can use for mating. So that's going to help you there and benefit you. There's, of course, your planes. You can always refer back to your planes, which is always the best way to mate things, right, is by the origin and planes, because then you're simplifying it. You're not putting calculations into the features. Yeah, so you can round those edges off. And then because it's sheet metal, you have a flat pattern. And it's automatically calculating that information for you.
Chris says, makes me wonder if 014 has a rock pipe set up as a gauge table. Because he says, I do not know because I do not use gauge tables.
Oh, wow. Use the gauge tables. They do actually, 856 and 14 share the same gauge tables. Yep. So I'm not going to go a whole lot into that because that's just basic sheet metal modeling, right? And doing some fillets and having a flat pattern. So I'm not going to go too much into that. That's just a great explanation of why you should use sheet metal for rod and pipe. Nope, didn't want to do that. All right, here's the final slide in this presentation. This is a troubleshooting moment that I had. Does anybody know what this is? Anybody guess at what that is? Fire pit. Yep. So my kids play football for the Unicoi County Blue Devils just over the mountain. And, you know, it was said that they wanted to have a bonfire for when they win. Of course, right after it was built, it was like, we lost. Can we still have a bonfire? So it was really just a social gathering point for most of the football team. All right. And it was really cool because you put the fire in there and you got the Blue Devil's head. I'll actually kind of show you the model of it. You got the Blue Devil head on one side, Blue Devils, you got the football, and then of course Unicoi County, the Blue Devil football team kind of on the other two parts of the triangular quadrants, I guess you want to call it. But the problem here was not really the way it was drawn, but the way SolidWorks wanted to unflatten it, or wanted to flatten it, or should I say, not be able to flatten it. Right. So I did it as a tab extrude, as an open contoured design, right? Instead of closing the contour, I kept it open because I knew the radius that I needed to have. I knew when they put it in the roll former, what we were able to meet when we rolled the piece of metal. Right. So I went ahead and did it that way, and I extruded it to the inside, and I did about mid plane and took it to, up and down the height I wanted. And then when I went to flatten it, what the heck? No flat pattern. Can't get a flat pattern. How did I do that? How did I get the flat pattern? I got a flat pattern because if we look at the drawing for this, and I probably don't have it on here, but I do have it in the slide. How did I get that flat pattern? Well, I went out of the box and decided sheet metal wasn't the time to flatten something, but surfacing could do it. If you have a problem flattening something, use surfacing. Surfacing will pick a surface on something and flatten just about any dang thing you want to flatten. Right? So that's what I did. I went to surfacing. And then I said I wanted to, where's it at? I'm looking for buttons. Remember, I've got hotkeys for this stuff.
Look up at use the search feature. S
Yeah,
key.
use your S key.
S key. Flat. I think it's labeled flatten surface. No?
For surface flat.
Surface flatten, maybe. Did I?
Yeah, it's straight out there.
It is grayed out.
Yeah, you don't have any surfaces. You don't have any surfaces. You can be grayed out.
Yep, gotta create the surface. And don't have to extrude it very much. Just extrude it by a 16th or whatever the sheet metal is. Must be specified. That got the surface. We can link it to thickness if we really wanted to. Is it not giving a direction? Is that what the issue is? The direction of the extrusion must be specified. I thought I had the direction. All right. Yeah.
Find the offset. Well, we would just use the offset surface.
Yeah, the offset surface command. He's correct. Yeah.
I don't have a dimension in there now though.
So get out of surface extrude here and try offset surface. Offset surface.
Yeah, and this one you did offset to 0. Yeah, exactly what I was getting ready to say. All right, now that I've got the surface, then I can come back and I can flatten it. Still not there. No.
We broke it.
I have a surface body here. It's been done. I've done it. So I don't have my files on this computer. I pulled over just what I needed.
Sure, blame the computer.
No, I'm blaming me not pulling all the files over.
Hope the camera went
Stop. Oh. Yeah, it's right here. It's straight out.
You try hiding the body.
We got the surface body.
Yeah, try hiding the solid.
Tab to hide body.
Yeah. It's hidden, isn't it? If I had, yeah, there it goes. I hid that time. Yeah, it's just not recognizing the surfaces there.
Save. Save it first. I'll try it. Nope.
It's not recognizing the surface at all.
Interesting. We found the bug.
Because we can extrude the surface and give it the 16th reference. Oh, the direction, yeah, I see it now. It's collapsed. That's just direction 2. Direction's there.
But it's not allowing me to give you a direction.
Yeah.
We've officially done it. We've broken it.
We broke it.
He said, can you pick the direction? Chris says, can you pick the direction under the line?
Oh, let's go back. Bring that back. Now let's go surface. Surface extrude. Surface. I picked you. Do it.
It's a premium feature. Oh.
That's what it is. So in our haste to try and make sure we had SolidWorks downloaded and didn't have to worry about our VPN, we checked out SolidWorks and it wouldn't let us check out our premium feature. So we are actually running SolidWorks standard. So for everybody out there, yes, it would have worked like I originally intended if I picked the surface and I could have actually flattened the surface. Problem being is we didn't check out the professional because it wouldn't let us. Or premium, I'm sorry. Yeah, we're just running SolidWorks standard for these presentations.
You just did it.
Nick just did it? Awesome, Nick. Thanks for verifying that, because I know I did it. I know I wasn't going crazy. I knew how to do it. It was just, yeah. So it's the fact that we were only able to check out standard instead of premium. That's what happened. Didn't want my presentation to go down the drain with the last presentation slide, but we did. And that's what these user groups are for. Yeah, because I would never thought that flattened surface was a premium tool. But now we know the rest of the story. The more you know, they want you to do. So be careful with that. All right. So yeah, that was a really interesting concept that I came across and had to figure out how to flatten it. And that's what I came up with, and it worked. I was able to roll it. Although I will say some of these rolling parts, if they didn't catch, it's just FYI, if you ever do something like this. Yeah. Awesome. Awesome. Yeah. So, yeah, if you ever do something like this, just a little FYI that when you do put things on a roll former and they're kind of sticking out there in the air and it doesn't catch both rollers, which should be common sense, it doesn't really roll great and it kind of stays straight. And so then you got to kind of do some, yeah, minor hand and hammer adjustment. Little tweak it. Already went to the CAD lab. So just some general notes that you may have wrote down or packed away in the old noggin to take for future reference is that gauge tables are super important. They make everybody stay on the same page and make for consistency and reduce the fat finger errors, right? Second note, almost anything can be unfolded. We just got to think outside the box and have premium. The third thing would be tab and slots can help you make for alignments and help the design for manufacturing process, but just remember that they have to have external links if you use the feature that has been implemented from 2019 SolidWorks. Detached flanges can help be within parameters. What time is it? 8:09. Yeah, so we're pretty much out of time. I can show you that, Chris, on the side if you want to holler at me. It's pretty easy. It's basically just making a plane somewhere and putting another tab on it and just connecting it. Cool. But detached flange can help you stay within parameters. What I'd like to tell everybody, and Tank's already said it, is no matter where you go, what you do, whether it's within SolidWorks, outside of SolidWorks, your daily life, but especially being that we're in a SWUG environment now, is give it a try. Take at least one thing back with you and put it to use. Of course, you're not going to remember everything we said today or everything you've heard all week from us, but if you could take one thing back with you and try it, and if it sticks and you like it, keep running it. If it not, throw it out and try the next thing. But start with the basics and create it with intent. Learning never exhausts the mind, said Leonardo da Vinci. And then Yoda said, seeing, then doing, you learn by. Of course, he didn't say that. I think it's just